So we're still on problem 7 of the MIT Integration B qualifying exam 2010. And here we have a second part of it, just a second version of the solution. We call it part 2. So I hope you stick around and see a much shorter, simpler version of the solution. So the integral itself is the definite integral from x equals to pi over 4 to x equals to pi over 3 of 1 over sine x to the power 3 times cosine x to the power 5. Now, as we said previously, sine x to the power 3 is equal to sine cube. This is the normal way of writing it. It is not equal to sine x cube, right? So the first thing I would do is I would simplify it, and the normal thing is I would want to use a substitution of maybe t equals to tangent of x. And how I could do that, I know the derivative of tangent x is sec squared x, and so I would pull the cosine x squared or cosine squared x aside, so that when I take it to the numerator it becomes sec squared x, right? And so at this point now it's very easy to see that the sec squared x dx can be substituted away with dt. Right. So my first thing to do is, since we have 1 over sine x cosine x the power 3 here, I could express this as partial fraction, right? And this is the same as, I mean, you can go ahead and prove it, but same as cosine x over sine x plus sine x over cosine x, so that when you multiply the denominator and this becomes cosine squared x plus sine squared x, and which is equals to 1, and then sec squared x dx. Now this using binomial expansion, with binomial expansion we have 1 for the power of 0, 1 1 for the power of 1, 1 2 1 for the power of 2, 1 3 3 1 when you have the power 3. So these are the binomial coefficients. So, and that's why I've used 3 here, and then obviously this is the first part squared, and then the second part, and then again 3, the first part, and then the second part squared, and then obviously the last one with the coefficient of 1, and the last second part cube. So this is easy. This becomes 1 over tangent cube x, and here, since we see this 2 and this go and this 2 and this go, so we have 3 cosine x over sine x plus 3, and so we see this and this go, and then this and this go, so we have 3 sine x over cosine x, and we have tangent cube x. Right. And as we proceed, we see that this part here is the same as 3 over tangent x, and this part here is the same as tangent x, and this part here is obviously just tangent cube x. So now we can now easily substitute for tangent x. We say let t be equal to tangent x, and that means dt dx is the same as sec squared x. That means dt can be substituted for sec squared x dx. And then for the limits, when x equals to pi over 4 tangent x is 1. When x equals to pi over 3, tangent x is root 3. So now we can substitute in for the limits as shown here, and then 1 over t squared, 2 cube, 3 over t, 3t plus t cube. And then for this part here, we just put dt. And then when we integrate this, the same as negative a half t to the power negative 2. Integrate this is 3 log natural log t. This is 3 over 2 t squared. And this is 1 over 4 t to the power 4. So at the upper limit, when t tends to root 3, we have negative half over 1 over root 3 squared plus 3 log of root 3 plus 3 over 2 root of 3 squared plus 1 quarter root 3 over 4 minus 1 over 2, in substitute 1 here, 1, and then here substitute 1, natural log 1, and then 3 over 2, 1 squared, and then a quarter, 1 to the power 4. So this goes to 1, this goes to 1, this goes to 0. And so as we go ahead, this is the same as root 3 squared, the same as 3. So we have negative 1 over 6, and here 3 log root 3. And then this is 3 times 3, 9 over 2. 9 over 4, because this is root 3 to the power 4 is the same as 3 squared, which is 9 over 4. And then here negative minus negative half plus this again tends to 0, and plus 3 over 2 plus a quarter. And so taking the product of 6 and 4 as a common denominator, 24. 24 divided by 6 is 4 times 1 is negative 4. And then here we have 24 divided by 2 is 12 times 9. 12 times 9. 24 divided by 4 is 6. 6 times 9. And then here 24 divided by 2 is 12. Negative negative becomes positive plus 12. And minus 24 divided by 2 times 3, that is 12 times 3, minus 24 divided by 4 is 6 minus 6. And then this part here just remains like that. So we continue. The answer here is 128 over 24 plus 3 log root 3. And then here by 8 we get 16. By 8 we get 3. So we have 16 over 3 plus 3 log root 3. And that is the answer that was provided. This was definitely a much simpler way of doing it. Initially we provided a more complex way, but math is cool. So until next time, it was nice hanging out with you. Be blessed. Bye bye.